we need to learn a term called as potential gradient. Now, you guys have used the word gradient before. Think of it. Don't read anything on the screen. Close your eyes. Think of it. It's a fancy way of talking about slope. How fast something is changing. Rate of change, basically. Now, potential gradient will do with what? How fast the voltage is changing. As simple as that. So, voltage has to do with from one point to another point. If you're moving, what is our potential difference? But in this case, the idea of how fast it is changing is what we are looking at. So we basically, it's a slope that we will figure out in a voltage distance graph. So the official definition is rate of change of potential with distance is called as potential gradient. And it's nothing but dV by dr. Where is that we have seen this? This is from, yes, minus dV by dr, right? Let me just put this. Okay, guys. So we'll be using this concept, what I'm going to show you guys now. So we'll be using this, but I thought I'll introduce it over here. So we need to understand something called as contour mapping from, say, a normal photo. What does it mean? See, we are looking at a hill or a mountain, whatever you guys want to think of it as. So see, if I pick up any point, right, we'll have certain set of points which are at the same height. Say here, if I pick up, there are certain point on the physically on the mountain that they are at the same height. For example, if I pick up this point, say all of this set of points are at the same height. If I pick up the ground, all of these points are at the same height, right? So maybe a bit more, maybe this is a bit, it has a bit of, depth. So if I pick up, say, this height, this is convenient. So maybe all of this are at the same height. Now, if I put this, see, this is 3-dimension. If I put it on a 2-dimension, it becomes a contour map. So here, if I talk about the idea of gradient, right? This from the top to the bottom, this has a lot more gradient compared to moving from, say, this point to this point. Okay, so let me actually show it with different layer. From the top, I want to go to the bottom. Of course, there are infinite possibilities of us moving down, but I'm picking up 2 possibilities, right? Something like this. In both the case, the change in height is the same, but at what pace we are changing, it's different. Agree? Basically, what I'm trying to tell is from this point, I'm trying to go down. I can go this way, or I can go a bit in this manner. This is a lot more longer, yes, and also the rate at which the slope is changing is not that steep. Here it's very steep, a bit dangerous, right? Over here, is it not? While over here it is okay. Basically, here the gradient is a lot more than the gradient at second path. Okay, so remember, I'm sure some of you might have seen this contour mapping, right? So contour mapping, here we will use it again to study something, of course, to study with potential only. But where and when, I'll be showing that, but I thought I'll just introduce the idea. So what is that we looked at? We have seen that we can derive the idea of electrical field of a space by looking at the rate of change of voltage with respect to distance. So this has a particular term. This is nothing but your gradient, right? Gradient of what? Voltage, potential gradient. And if we draw a voltage versus distance and space graph, right? we might end up with such scenarios, and this will have a lot more gradient than this. Okay, you just have to know the term. We'll have another video talking about the mapping and all of that, so we need to know those. Actually, it is much easier than what we are trying to tell over here. Yeah, for now, just know that potential gradient has to do with rate of change of potential with respect to distance. That's it.